In this domain of linguistics, we have already talked about formant frequency, fundamental frequency. We have not talked about harmonics, but what I'm going to do today is compare formant frequency and fundamental frequency and see if they are the same or related, and introduce the concept of harmonics. To do this, we need to review what we did before. Fundamental frequency, formant frequency. The formants are the sounds that are produced by the vibration of the vocal folds that are played in the larynx or voice box. These sounds, which is speech sounds, are amplified in the cavities above the larynx, which are the pharynx or oral cavity, where certain frequencies but not the others are resonated. Each of these resonated frequencies is a formant. In other words, formants are peaks or maximal points in the sound spectrum. As I will show in the picture, they are bars of intense sound energy, each associated with the frequency. As you can see in the picture, we have 8 separate sections in this spectrogram in which the vowels, 8 vowels, are shown, and in each vowel, using arrows, those bars of intense sound energy are shown. And each arrow can be measured in terms of frequency, which is the vertical axis on the left. The first formant, which is the bottommost, the one at the bottom, it's formant number 1, F1, is typically below 1000. Here you will see the same vowels with the numbers indicated. Starting from the top to bottom, you have F1 to F3, formant 1 to formant 3. For each vowel, you have the exact frequency. So if you want to imagine a vowel as a picture, you can look at this spectrogram and think of these bars. And then if you're more of a number person, you can always remember these numbers with these bars. See, each vowel has its own combination of formant frequencies, and that's how these formant frequencies are significant for the identification of vowels. Each formant is associated with a darker bar of more intense energy in the sound, or more intense sound energy. From bottom to top, the first 3 such formants are significant for the analysis and understanding of speech sounds. Higher bars with higher frequencies speak to a person's voice quality. If I want to understand your voice print as a person distinct from me, I would look at formants above the 3rd formant, but not for the general analysis of vowels. So here I have a different chart, which is an example of the 1st and 2nd formant frequencies in vowels. As you can see, these are the vowels U, A, E. The frequency of the 2nd formant increases as you move from U to E. But if you look at the 1st frequency, you will see that the frequency of the 1st formant for U and E are kind of very close. But for A, it's higher. This shows an inverse relationship to tongue height. For the 1st formant, the higher the vowel, the lower the frequency. Although the vowel U is a back vowel and it's rounded, and the vowel E is a front vowel and it's unrounded, they both have the same height. So they're both high vowels. And you see that they both have a low 1st formant frequency, which means that the 1st formant has an inverse or opposite relationship to tongue height or vowel height. In other words, the higher the formant, the lower the vowel or vowel height. However, expressed in terms of openness, you see here, instead of high and low, you have open and close. You could say they have a direct relationship. So now I'm going to show you a different picture. What I do is I'm going to turn it upside down and put the 2nd formant at the top and the 1st formant on the left again, but the frequency is increasing as you go below. The 2nd formant is higher for E and lower for U. The 2nd formant is higher for E and lower for U because the 2nd formant is determined by tongue advancement. which means how front or back the tongue peak is. So far, you can see why formants are important. First formant is directly proportional to openness. Second formant is directly proportionate to frontness. Lip rounding lowers both the second and first formants. You see here, it has been flipped so that the second formant frequency decreases as you go to the right. Why did we do this? Because this is more similar to the vowel chart. Because U is on the right, E is on the left. Now you want to make sense of lip rounding. In the back vowels, U and A, U is more round than A. This will affect the first formant and the second formant as well. It means lip rounding lowers both the second and first formants. This is why U has a lower second formant frequency and a lower first formant frequency compared to A. I just wanted to show how this vowel chart is in a way defined based on formant frequencies. But typically speaking, when we're doing phonetics and we're not being very technical, we just talk about vowel height, back and front, tongue height, tongue advancement, and lip rounding. But those are defined based on formant frequencies. So if you want to speak in terms of frequency, you will use formants. You will say frequency. These three frequencies, the first three formant frequencies, define the three features of backness, height, rounding, which define every vowel. Of the three features that define every vowel, two have to do with the tongue, which is height and frontness or backness, and one has to do with the lips. Now, the purpose of this video was to compare formants and fundamentals. Now that I said enough about formants, let's look at fundamental frequency. The lowest frequency component in a complex sound wave. It is called the fundamental or F0 or first harmonic. You need to know that F0 is the first harmonic. It is particularly important in the understanding of intonation, where it closely corresponds to pitch. Fundamental frequency is not the same as formant because it is not a high intensity part of the sound wave. It is the lowest frequency component of it though. So what does that mean? So formants were the intense areas of sound energy. That's not what fundamental is. So in this case, for example, in this picture, we have the waveform for these vowels, for the vowels O, U, and E. And you can see that they all have the fundamental frequency of, all the vowels here is 100 Hertz because the pattern repeats itself once every 100th of a second. Harmonics. Now harmonics, or a harmonic, is a whole number multiple of the fundamental frequency. So, which means that in this wave, the fundamental frequency is 100 Hertz. The harmonics will be multiples of 100. If the fundamental frequency is 200 Hertz, the harmonics will be multiples of 200 Hertz. So the first harmonic is the same as the fundamental frequency, but the next harmonics will be multiples of that. So in a way, you could also say that the subsequent harmonics are multiples of the first harmonic. You need to know that in music, so if you have any music background and you're watching this video, you might get confused because in music, the first harmonic is the first multiple of the fundamental. In a way, when you study music, the first harmonic is actually what is the second harmonic in linguistics. A combination of the fundamental and amplitude of the various harmonics give a sound its characteristic tone and quality. To understand fundamental frequency, you need to look at the sound wave. It is the lowest frequency component in a complex sound wave. It has to do with the patterns in the sound wave. It's called fundamental because it is the frequency that is regularly repeated in every instance of repetition, which is a multiple of that frequency, is harmonics. Basically, F0 or fundamental frequency gives you the basis of the mathematical calculation of the harmonics.